IGCSE Computer Science, Syllabus Statement 1.1.1c, show understanding of the concept of a byte and how the byte is used to measure memory size. So, a binary digit is referred to as a bit. So like, if you remember binary digits like zeros or ones, if you put these two together, like the B from binary and the it from digit, we get bit. 8 bits are referred to as a byte, and a byte is the smallest unit of memory on a computer. Now you might be wondering, wouldn't a bit be the smallest unit of memory? Well, the thing is, a bit is, remember, a 0 or a 1, so that can't really store a lot of data. I mean, like, it's really small. Like, you can only store a 1 or a 0. Like, so just think about that. And, like, even a byte is too small to store a significant amount of data, which is why memory size is measured in the following multiples. So, like, if you have a text file or a movie, like most movie files, like MP4 files, are pretty, like, they're not so big, but they're like you know, like a 20-minute episode, 1080p would probably be like I don't know. I can't really estimate. Well, it's okay. It's pretty large, and it's usually measured in megabytes, which you're gonna find out what they are in a minute if you don't know what they are. So like, there's kilobyte, which is 2 to the power of 10 bytes, so that's 1024. There's a megabyte, which is 2 to the power of 20 bytes, and that's 1,048,576 bytes. So, like, that's 1 megabyte in bytes. So, like, as I was saying with the movie, like, a movie would... Okay, let's take a regular sized MP4 file, and let's say it's, say 100 megabytes. So, like, that would be, like, a normal, kind of short-ish movie file size, and that's pretty big. Like, so you can see why a byte is too small to store, like, anything significant. And then there's gigabyte, which is 2 to the power of 30, which is also a really large number of bytes. Then there's the terabyte, 2 to the power of 40. This is, again, an even larger number. There's the petabyte, 2 to the power of 50, and again, they just keep getting larger. Exabytes, zettabytes, yottabytes, and they're pretty huge. Most computers nowadays should be like a terabyte or two, I guess. Like, most old computers should be like 300 to 500 gigabytes, but like, I'm talking about laptops, not actual computers. It's like, I have a laptop and I don't actually have... I didn't have a desktop for, like, since a few years back, but anyway. There are also bit multiples. So, like, along with kilobyte, megabyte, gigabyte, there's also kilobit, which is 2 to the power of 10 bits, megabits, and so on. So, bit multiples versus byte multiples. So, we remember that 1 byte is 8 bits. So that would mean that 1 kilobyte would be 8 kilobits, 1 megabyte would be 8 megabits, and so on. So you might get a question in the exam, like, the upload speed on the internet is 32 megabits per second. How long would it take to upload a 40 megabyte file? So, first you convert 32 megabits into megabytes. So remember that 1 megabyte is 8 megabits. So it would be 32 divided by 8, which would give you 4. So 32 megabits is 4 megabytes. So that would give us 4 megabytes per second, because it's megabits per second here, 32 megabits per second, so that would become 4 megabytes per second. And we have a 40 megabyte file, so easy, 40 divided by 4 gives us 10, so 10 seconds to transfer.